So it's good to see you all here again. I'm Natasha and welcome back. So today we're going to continue our chapter 2, relations and functions, as usual. So in this video we're going to solve some questions and we're going to discuss about an odd function and an even function. Okay, like I've already told you about this in the previous video also. Yeah, and in the previous video we discussed about algebra of real functions, in which we, mainly had discussion of addition of two real functions, subtraction, multiplication by a scalar, and multiplication of two real functions, and the last was division, which I can say the quotient. Okay, so we have some questions here, so let's solve them. So let's get started. Okay, so the first question we're having is if A cross B is equal to, okay, so this is kind of a cross product of these two sets were given to us. So what do we have to find? Find set A and set B. Okay, so we have to find the set A and set B. So it's really easy, as we all know. One thing that we have to just focus on is what's coming in the first line. So what's coming first? Is it set A or set B? So I can see that set A is coming first. So according to set A, all the first elements of all these pairs will be the elements of set A. And the second elements will be all the elements, and the second one, will be all the elements of set B. That's just clear. So let's just see. Okay, so we're having two elements only in the first element, as I can say A and B. And there's just repetitive, okay? So it's kind of like it's repeating that. So what I can see and what you can also see is that there are only two elements. I can say elements, A and B. That's it. No other elements in the first element. So what I'll say is set A. Oh my gosh, why isn't it working? Okay, I'm going to change the marker. Just a second, and let me just clean this off. Okay. Yeah, so solution. Set A is equal to the elements A and B. That's it. Now let's just move on to our second set. It's set B. So set B is equal to the elements. What I can see is there are like 1, 2, and 3. 1, 3, and 2 is again repeating. So so what I can see is that there are only 3 elements, 1, 2, and 3 in the second element. In the second elements of all these pairs. So 1, 2, 3. And yeah, it doesn't matter to the order we're writing, so we can write it in any order, like 2, 1, 3, 1, 3, 2, or 3, 2, 1, whatever. Okay, as I've just written in the simplest way, 1, 2, 3. Okay, so we've done the first question. The first question was really, it was really a piece of cake. So we have finished it, so let's just move on to our second question. Okay, so let's set, so we have 3 sets, set A, B, and C. Okay, and their elements were also given to us. Set A is equal to the elements 1, 2, and 3, and set B is equal to 3 and 4, and set C is equal to 4, 5, and 6. Okay, so we have to find 3 things. Okay, so it's given in 3 parts. First part, we're gonna have a look at it. So A cross B intersection C. Okay, so we have to just find the cross product of A and B intersection C. So first of all, let's find B intersection C. Okay, so B intersection C is what's common. So I can see 4 is only common. It's only common. So what I'll say is, and what set A it is 1, 2, 3. Okay, cross 4. Now they're crossed. I'll get 1, 2, 4, 2, 2, 4, and 3, 2, 4. Isn't it? 1, 2, 4, 2, 2, 4, and 3, 2, 4. So as you know, A was coming in first, so it was coming. Set A was coming first, so according to it, I just did the cross product. So from the elements of A to the second, as we're having B intersection C. Okay, that's what I did. So 1 to 4, 2 to 4. As there are only one element, so I've just did relation with them. Okay, so we've done and we found out this. We saw first part. Now let's move on to our second part. Second part is A cross B intersection A cross C. Okay. So first of all, let's see the A cross B. It is going to be a little big. 1, 2, 3. Then 1, 2, 4. Then 2, 2, 3. And then 2 to 3 and 2 to 4. And then 3 to 3. And then the final 3 to 4. Okay, so this is A cross B. It's actually big. So now we're gonna have a look at the A cross C. So which I'm just going to write here, okay? So A cross C is with the A cross C. Okay, it's gonna be more big. Never mind, we don't have any problem. Okay, so first we're gonna have is 1 to 4. Then wait a second, let me just rub the third part. Okay, I'm just gonna write it a little further there. Okay, so 1 to 1 4 or 1 to 4 and then 1 to 5, 1 to 6. One's done. So let's move on to our second. It's 2 to 4, 2 to 5, and 2 to 6. Okay, now 3 to 4. Now 3 to 5, and then 3 to 6. Okay, done. So it was kind of really big. So let's have a look. How many pairs are we having in the first? Okay, there are 6, and their total 1, 2, 3, 4, 5, 6, 7, 8, 9. So I can say that there are 9 pairs and 6 pairs we're having here. So, and I'm going to write the third part here, which is A cross B union A cross C. Just right, it's opposite. In this one, we have to find the intersection. In this one, we're going to find the union. Okay, so another intersection, like what's common? So I can say the first pair that I can just see is, okay, this is kind of confusing. Okay, so I can see 1 to 4 and 2 to 4 and then 3 to 4. Nothing else, okay? So the intersection of them came as 1, 2, 4, and then 2 to 4, and then 3 to 4. So there we got 3 pairs. It's 1, 4, 2, 4, and 3, 4. So what's common? What I can say is that what if I have to find set B and set A in for only this thing, just like in the suppose that was given to us. And what I will say that what if we have to find set A and B according to this pair, okay, given right here. So set A will be 1, 2, and 3, but set B will be only 4, as we can see that all the second elements are 4. Okay? Okay, no need to mention it in a box. I don't want to trap it. Okay, so let's just forget about it. So let's move on to our third part, the last part of this question. So it's A cross B. So I'm gonna write this exactly right here too, and this one too. So wait a second. Yeah. So it's 1, 3, 1, 4, 2, 3, 2, 4, 3, 3, and 3, 4. And this brace close. Now union 1, 4, 1, 5, 1, 6, 2, 4, 2, 5. Oh my gosh, there's no more space left. This has become a little spongy, a little too crowded. I want to have them. Okay, so let me make some extra space. 1, 4, 1, 5, and then we have 1, 6, and then 2, 4, and then 2, 5, 2, 6, 3, 4, 3, 5, 3, 6. Okay, feel done. Whatever. Yeah, so I'm done, and I hope you will not get confused as I'm not gonna make any line. So it's union this. So union is like we're gonna write all of them. So let me just, write it. Just write. No, not right here. Okay, I'm gonna write it right here. Yeah. So it's gonna be 1, 3, 1, 4, 1, 5, 1, 6, 2, 3, 2, 4, 2, 5, 2, 6, 3, 3, 3, 4, 3, 5, and 3, 6. It's done. So how many pairs are we having? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so there are like 12 pairs. So what I just saw that here on, the union of 2 sets, and the pairs are like 6 with the 9. 6 with the 9, we got 12 pairs, isn't it? Yeah, it's actually 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Of course, it is 9. And it's 6, so 6 to 9, and it gives us 12 pairs. Okay, so we've done all the 3 parts, and that was like kind of, the third part was a little too, kind of too big, too long. So, okay, so let's move on to our next topic. So we've done these 2 questions, and now we're going to discuss about 2 functions. Those are like really small functions. Even function, and second one is odd function. Okay, so even function. So let's say I have a function f, as usual, that we can usually see in any function. Take an example as f. So even function. Even function. A function f is said to be an even function. An even function if let's say I have fx, f of negative x is equal to f of x, okay, and the odd function just write its opposite. So I'm going to write the whole statement same, but the difference is going to be in this last thing. So a function f is said to be an odd function if f of negative x is equal to negative fx. Okay, so just have a look at these two statements. Got it? Okay, so what does this exactly mean? So I'm just going to take it in a real easy way. So according to, for the even functions, a function f is considered to be an even function only if f of negative x is equal to fx. So what does that mean? F of negative x means the x value that we're having is actually negative, and if the f if you know the function of negative x, so if f of negative x is equal to the f of positive x, then we're gonna say that function as even function. But if in odd function, but if a function's like it's having the same, it's in the same situation but getting in different, like the same output we're entering in it, but we're getting a different output. So I'll say this as input, as both are same, output we're getting different. So for the even function, I hope it's clear. So for the odd function, it's saying if f of negative x is equal to negative fx. So what does this mean, negative fx? Can you tell me what does this negative fx mean? What will this negative fx mean? So it's saying, in this condition, it was just saying that if the f of negative x means the value we're having is negative, but not related to the function. So we're actually doing the function of a negative value, okay, input value, as I'll say, is equal to fx. It's just saying f of positive x. But in the odd function, it's kind of different. When we, when f of negative x is equal to negative fx, then that function will be, it's going to be considered as odd function, okay, as an odd function. So there's nothing to a difference. So it's saying that the x value we're having is actually, we can't say that the value is negative. In this case, that it was negative, but after just getting it, so we got the whole thing negative fx. So if we got negative in any of the functions, this means that it's going to be odd. But if we got the positive value, then it's going to be even. So it's just a negative for the odd and positive for even. That's it, nothing else. So what was the difference? That it was just positive and this one was negative. That's what we can see. Only the difference of the sign, the minus sign, isn't it? The negative sign. That's it. So even function, odd function. So we're going to solve some questions on even function and odd functions too, but in any other video. So that's all for today. Thanks for watching and have a great day.